For decades, we built AI like we build hand tools, one for every specific job. If you wanted a translation, you built a translator. If you wanted a summary, you built a summarizer. Today, we're moving away from those one-trick ponies toward a single generalized system that can do it all. Before large language models, AI was fragmented. Every new problem required a brand new model, a new dataset, and a new engineering pipeline. This approach simply didn't scale because the more complex our needs became, the more siloed our AI tools felt. LLMs changed the game by learning the general structure of human language across millions of different domains. Instead of being hard-coded for one job, this single engine internalizes patterns that allow it to perform hundreds of tasks without being explicitly programmed for each one. Human language naturally encodes our reasoning steps, factual knowledge, and communication styles. By training on massive collections of text, an LLM soaks up these patterns, allowing it to apply that same logic to almost any task you throw at it. When we call these models large, we are talking about their scale, specifically the billions of parameters or internal values they adjust during training. Earlier models were too small to understand the why behind language. They could only mimic the how it looked on the surface. As we increased the size and data for these models, a clear shift appeared. They started following detailed instructions and performing multi-step reasoning. These capabilities weren't programmed by hand. They emerged naturally as the model gained enough capacity to understand deeper relationships in language. Think of a standard LLM as a talented intern. They are eager and fast, but they often need clear direction and a specific brief to stay on track. They have the general knowledge to help, but they haven't yet specialized into a professional contractor. We are now moving beyond just chatting with AI. We are entering the era of agentic AI, where generalized models act as the brain for a system that can actually get things done. It's the difference between an AI that tells you how to book a flight and one that actually goes out and does it. A traditional AI follows a fixed path. If it hits an obstacle, it breaks. A generalized LLM acts like a dynamic GPS. It understands the goal, observes the traffic of new information, and recalculates the path in real time to find a solution. Why does this shift matter? It means you no longer need to find 20 different apps to solve 20 different problems. By mastering a single generalized engine, you gain a partner that can adapt to your specific workflow, whether you're a coder, a writer, or a researcher. To make these generalized systems work for you, you must focus on context engineering. The quality of the AI's output depends less on the model's brain and more on the richness and accuracy of the information you provide it. We cannot simply overlay these powerful tools onto messy, inconsistent data. To truly benefit from generalized AI, we must build the Interstate system, clean data, and well-defined APIs that allows these agents to operate at high velocity and with total trust. To recap, we need LLMs because task-specific AI is too slow and fragmented to solve complex real-world problems. By moving to generalized systems, we gain a single, powerful engine that can reason, adapt, and eventually take action on our behalf. The future isn't about replacing human ingenuity, but about augmenting it. We are moving toward a world where you aren't just an AI user, but an AI architect, orchestrating a team of intelligent partners to solve the world's most complex challenges. The canvas is in your hands and the patterns are yours to use. It's time to stop just using AI and start engineering the future. Thank you for watching.